Hi, I am Lopamudra Sen. Welcome back to my channel Electronic Science Tutorial. From today I will start a new lecture series on NTA UGC NET and West Bengal SET exam for Electronic Science subject. Those who are not check out my channel, please follow my channel. If you like my channel, then please do like, share and subscribe my channel. So let's start our class. In today's class, we discuss about the NTA UGC NET and West Bengal SET exam 2022. In this session, we cover in detail about this topic so that we can easily solve the previous year question paper of UGC NET Electronic Science. Each and every topic we can understand in easy and simple manner. So, let's begin our NTA UGC NET exam 2022 class. Okay. Today I will discuss about next important topic of extrinsic semiconductor, that is position of Fermi level for p-type semiconductor. We know that is extrinsic semiconductor is two type. One is n-type semiconductor. In previous class we already discussed about this topic, that is the position of Fermi level for n-type semiconductor. Today I will discuss about the position of Fermi level for p-type semiconductor. So what is p-type semiconductor? P-type semiconductor means pure semiconductor or intrinsic semiconductor is doped with group 3 element. Group 3 element means like indium, boron, aluminium, gallium, and which creates excess holes, right? So this is for p-type semiconductor, and for p-type semiconductor the majority carriers are holes and the minority carriers are electrons, right? We already discussed about this topic. So now we saw the position of Fermi level for p-type semiconductor. So this is the energy band diagram or the position of Fermi level for p-type material. Okay. So this is conduction band, this is valence band. We know the distance between the conduction band or gap between the conduction band and valence band is called forbidden band gap or energy gap. Okay, which is different for germanium material and for silicon material. And we also know one acceptor label which is introduced in p-type semiconductor. Acceptor label, where acceptor label lies top of the valence band. Top of the valence band acceptor label lies and it is denoted by EA, right? So this is the acceptor label and this is for holes. This label is created for holes, right? So this is the acceptor label and this is lies near the top of the valence band. When this acceptor label is created, that means the complete ionization of the acceptor atoms at a finite temperature is also created. That means we find that one free holes coming from the acceptor label fill the states near the top of the valence band. Hence it is more difficult for the holes in the valence band to cross the band gap of the thermal by the thermal agitation. Therefore, the number of holes in the valence band decreases. Therefore, the number of electrons in the conduction band decreases. And what is the Fermi level? Fermi level means highest occupied energy level. So as the Fermi level is the energy for which the probability of occupancy is half, EF must move closer to the valence band for an p-type semiconductor. If the doping is very high, the Fermi level moves to the conduction band for n-type semiconductor, and for valence band or for p-type material, it is close to the valence band if the doping is very high, right? And as the temperature of the semiconductor rises, the temperature of p-type semiconductor is increases, the Fermi level moves towards the center of the band gap. Okay, so this is the position of Fermi level for p-type semiconductor. That is, the Fermi level lies at the edge of the acceptor level or the valence band. For intrinsic semiconductor, Fermi level lies middle of the conduction band and valence band, or the middle of the forbidden band gap. But for p-type semiconductor, when excess doping is done, then the Fermi level moves into the valence band for p-type material, and near the valence band edge one acceptor level is lie, and near this the Fermi level is also lie. So Fermi level is closer to the valence band for p-type semiconductor at 0 Kelvin. So this is the position of Fermi level for p-type semiconductor material. Okay, I hope you understand this topic. Thank you. Thank you. I hope you love this informative session of NTA UGC NET or West Bengal SET exam. If you like my video, then please do like, share and subscribe my channel. फिर मिलते हैं एक नई वीडियो के साथ. Thank you.